In this video, we're going to have a look at how we can find the equation of a line that passes through 2 points and has a predefined gradient. Now, the trickiness factor of this particular question is amplified that we have two unknowns. So there's a y1 and an x2. And what this means is that the 2 points that we're given, we don't have all the information, so the points themselves are not completely constrained, or they're not completely defined. So what we'll find is that if we try and graph something like this, so if I draw my Cartesian plane, we know that the particular line, it's got to have a gradient of m equals 0.2. So the equation itself, we know that it's going to be y equals mx plus c, and we know the gradient is going to be 0.2, so it's 0.2x plus c. So the question at hand is, what is this c value going to equal? So our c value here. Now, if we graph what we currently have, then we'll find that it can look something like that, or it could look something like that, or it could look something like this. And what we're told is that we know the line itself has to pass through this point here and this point here. And notice y1 is undefined. So all we know is that it has to pass through negative 2.5, or x equals negative 2.5. So if I show that on the line as such, this would be x equals negative 2.5. And on the other one, we see the y value. So the x2, that's undefined, but the y value is 1.5. So that would be somewhere like this. So y equals 1.5. So what you notice is that the line has to touch these 2 points. And if we move the line up and down, shifting this c value here, the line can go upwards or it can go downwards. And as it moves up and down, it's still going to touch these points here and here. So what we can see is that there are multiple solutions to this problem. Now, it simply asks us, we have to find an equation of the line that passes through this point. So although there are infinite amount of solutions, we just have to find one. So what we can do is we can simply say, let's fix the value of, let's say, we'll take this one here and we'll fix it such that we'll say, let x2 equal 0. And by doing this, we constrain one of our points. So we've still got negative 2.5 and y1. And then we've got 0 because we replace the x2 there with 0 here. And then it's 1.5. And that has a gradient of 0.2. So awesome, going downwards. How can we find the equation of this? Well, simply by grabbing these points here and these points here, or this gradient here, we can test when we say a line passes through this point up here and has a gradient of m equals 0.2, we can find the constant, so that guy here, which will tell us a line for this particular solution. So writing it out, we know that y equals mx plus c, and we know that m is equal to 0.2, so it becomes 0.2x plus c. And here's where the magic begins. We're going to say let x and y equal these values up here. So 0 and 1.5. Substituting those into the equation, we have a y value of 1.5 and then 0.2 times 0, so x we're saying is 0, plus c. Now, solving for c, we have 1.5 equals 0 plus c, and therefore, rearranging, we find c equals 1.5. So what we see is that the equation or a solution to this question would be y equals 0.2x plus 1.5. Now, this would be an acceptable solution here as such, but to finish off the question, what we could say is, well, okay, if we're going to use this equation, what would be the value of y1? Well, to solve that, going up, we need to find what is the value of y when we set x to negative 2.5. So I'll put the points here. So negative 2.5 and y1. And our model is y equals 0.2x plus 1.5. Now highlighting what we want to sub in. So we're going to sub in negative 2.5 for x, and then we're going to find the value of y. So subbing it in, we've got 0.2 multiplied by negative 2.5 plus 1.5. And whoops, we got y1 there. Now, negative or 0.2 times 2.5, not quite sure what that is, so I'm going to go get my calculator. And it is 0.2 times negative 2.5, and that is negative 2.3. Interesting. So, negative 2.3 plus 1.5. Adding these two together, therefore y1 we see is, bringing my calculator back, I'm going to add 1.5 is negative 0.8. Thus, we find that we have negative 2.5 and negative 0.8. Going up, what was our other coordinates? x2, so we said x2 was, we set x2 to 0, so we'll go 0 and 1.5 with a gradient of 0.2 has or creates an equation which is 0.2x plus 1.5. So over here, it's quite a long solution, but it is a solution, or one of infinite solutions, to this particular problem here in part A. Now, what